Welcome, my dear NEET warriors. Welcome, all my lovely class 11 students. This is your Captain Shreyas, your physics master teacher, and I have been training kids for more than 13 plus years and making you achieve your dream of becoming a doctor. Today morning only, I saw one very interesting story of one of my students who has now become a doctor, and he sent me, or rather he had posted it on the status, and then he also reshared because I was not following him on Instagram. So he shared that status from the operating room, and that thrill he had, that was really amazing. So he was getting ready. He didn't send obviously while he was operating, because obviously that is not allowed. Plus, number two, he's just started his practicing and everything. So, that gave me that immense joy. And you should definitely look forward for that day where you will be finally in that room. Yeah. So, welcome, Sai Kumar. Welcome, everyone out here. Welcome to the channel. And if you have not yet liked and subscribed to the video, like the video, first of all, subscribe to the channel right away, right now. And a lot of content is there on the channel, guys. If you have forgotten to watch any class or you are new to the channel, please go back. Okay, we have started off the 12th standard topics, right? We are already on to capacitors, vector resolution, representation, units, dimensions, already done. Even the basic maths concepts also already taught to all of you. So please check it out. Okay, basics of geometry, basics of algebra, everything is already being taught to you. So make sure you are watching all the classes. If you miss, please watch the recorded one, and notes, everything will be there in the description box later on. Okay, ready for it? Ready for it? So let's go with the flow, and let's concentrate on the topic now. I want your full attention, full energy, and get everyone into the classroom. Okay, so let's begin. Ready? Yes or no? Okay, let's begin. So see, guys, if I tell you, there is one Pandu, and he has two mangoes, or whatever, apples, two mangoes, and then he ate three more mangoes. Then, how many mangoes did he eat overall? You'll be like, 2 plus 3 is nothing but 5. Okay. Now replace this word mango with something else. Maybe replace it with, there is a pandu who is holding 2 kg of mass, and on top of it he adds more weight onto the thing. Maybe he adds 3 more kgs. He's holding 2 kgs of books, he holds more 3 kgs of books, so totally he will be holding 5 kgs of book. Same thing, let's say you replace the word kg with something else. Let's say Pandu is wasting 2 seconds of his time. He may waste 3 seconds more of his time. So total time wasted is 5 seconds. So these are just units, so really doesn't matter. This kind of addition is basically your scalar addition. This is nothing but your scalar addition, where direction is irrelevant, and there is no meaning of direction in these situations. Direction is irrelevant. Okay, it is not important, it is not having any meaning in such situations. But imagine this, that there is a beautiful champa, and champa's car has broken down, and now this particular champa asks Pandus, hey Pandus, can you help me out? So 3 different times this happens with the champa. So first time, one Pandu is pushing like this, and this Pandu is also helping this Pandu. So they are pushing in the same direction. This Pandu is applying 2 newtons of force. This Pandu is applying 3 newtons of force. In the second scenario, there is one Pandu like this, who is pushing it like this. Another Pandu is, let's say, over here, and he is pushing it like this with 3 Newton, this Pandu with 2 Newton. Another scenario, maybe this Pandu applies a force of, let's say, 3 Newton, and this Pandu applies a force of also 3 Newton. So 3 different days, Champa's car broke down and she found 2 Pandus, and this is what happened on all the 3 days. What will happen in the first scenario? As you can see, these 2 Pandus are pushing the car or the vehicle in the same direction. So what will happen? This vehicle will get a total push. There will be a total push of basically 5 newtons in this scenario. In this scenario, this Pandu is pushing from the front. They are not well coordinated. This Pandu is pushing from the back. So in all, what is the total force that the Pandus will apply? It will be obviously a net force of nothing but 1 Newton this way. 1 Newton towards the left hand side. The 2 from here and 2 from here will cancel out, and the remainder will be 1 Newton on this side. In this scenario, both the Pandus are applying equal and opposite forces. So nothing will be left. A null vector will be left. Null means 0 magnitude. So 0 Newton force will be there. So as you can see, 2 Newton, 3 Newton might give the answer as 5, can give the answer as 1, can also 3 and 3 can give the answer as 0. So many possibilities are there when you add the vectors. So when you add scalars, it's simple addition. But when vectors are added, so when you have basically, when you have vector 1, when you have vector 1 and you add vector number 2 to it, the resultant that you get, the final answer that you get, that is called as the resultant. This is called as the resultant, or basically the net, or basically effective. Whatever word you want to use, you can use. Resultant, net, effective, okay, the final sum. Okay, so this particular vector sum, the vector sum that you get, is not just dependent on the magnitudes alone, but also depends on which directions do they act. If the directions are different, obviously, you know, answer will change. Hi Rajesh, hereafter, can I take a drop this year? I have completed 12th. Yes, Rajesh, you can definitely take a drop. A lot of students do take a drop in the month of July as well. It's not that only in May or June only. A lot of students after the counseling, or they realize, okay, I'm not getting a seat, or I really want to get into IIT. Definitely a good time to start your preparation. So please get ahead of the curve and make sure you start from chapter 1 and make a plan to complete the syllabus by October end, so that you get enough time for revision for the first attempt. Okay, you know how this game works. So try to complete the syllabus properly with the JEE advanced preparation by October end. Okay, great. Right. Yes, 6 months is enough, Lone Rider. Yeah. Should I prepare for JEE in 10th, or should I focus only on boards? You should focus on both. It is possible, but when the boards are nearby, like 4-5 months, then only focus on the board exam, right? Okay. Now that you understand that the vector sum, this particular vector sum, the net thing which is there over here, the resultant or the net, depends on the magnitudes and the directions both. Here the direction was irrelevant. Here both magnitude and directions matter. So how do I show that addition of vectors? Here is how I show it. If there are one or more vectors which are being added, let's say vector A and vector B is giving you, let's say, vector C. So these are the vectors being added. These are nothing but the vectors which are being added. These are nothing but the vectors being added. And this over here is nothing but your resultant vector or net vector or effective vector or the vector sum. Okay, so this is how you basically show the vectors addition. It's also that vectors A and B can now be replaced by a vector C. So that is also the meaning of this equation. So maybe, say for example, you had one Pandu who was applying a force of A Newton and another Pandu who was applying a force of B Newton. Okay, I can get rid of both of them and I can have one singular Pandu, a single person who is doing the job of both of them, and that is C. So C replaces both A and B. A and B. Okay, so it is a kind of a replacement. It is the effective thing. So you give me 2 kgs and then give me 3 kgs is the same as giving me totally 5 kgs. Okay, same thing over here. You giving me 2 people who are applying A and B force or whatever vectors is the same as giving me one thing with a value of C with the same effective direction. Is this absolutely clear? Everyone, give me a thumbs up, then we'll go ahead. Cool. So, having said this, there are multiple ways of getting the final answer. How do I find the resultant, sir? There are multiple ways. First method is basically called as the triangle method of vector addition. So, what you do is you form a triangle basically by showing the two vectors being added as the two sides of the triangle. Then the third side automatically signifies the effective or the resultant vector. But notice how these things work, that the vectors being added, they have to be placed like this, where this is example the tail and this is nothing but the head of this vector number A. Then the other vector will start from here. That means the tail of vector B will be here and the head of vector B will be here. So it should go in correct order, tail to head, like that. Then the resultant vector which is there, the resultant vector which will be there, which is this one over here, it will again have its tail from here and the head on the final head, So the order has to be correct. You are going from tail head like this. So the resultant also tail to head, from tail to head. Okay, tail to head like this or directly like this. This is how the arrow marks should be. Please do not even add by triangle methods like this, which are the incorrect ways of adding via the triangle method. Like for example, this one. If I put vector A over here and then I put vector B over here, this is definitely not correct. Okay, and then I say, okay, this is my vector resultant vector. Wrong. This is wrong. Or even for that matter, I say this is my vector A and this is my vector B and then this is my resultant. This is also wrong. Or even this, let's say I put vector A over here and then I put vector B over here. Okay, vector A over here, vector B over here. But the resultant vector, instead of showing like this, I show it like this. This is also wrong, guys. This is also wrong. So all these things, my dear warriors, this one, all these are basically wrong methods of adding. Okay, so these are incorrect. These are all incorrect. Okay, so these are 100% wrong. Okay, all these three methods are wrong. This is the correct way. Everybody is clear about this, how we should place the tails and the heads of the vectors being added, right? Okay, right. Rajesh, just connect with me on Instagram or Telegram. Like my ID is very simple, Captain Shreyas. You can easily find me on Instagram or Telegram, on WhatsApp, everywhere. Okay, so just check it out. You will find it. All right. Definitely, why not, Rajesh? Okay, now next thing over here is, sir, when you're doing this triangle of vector addition, can you show me some more examples? Okay, why not? Here it comes. Imagine I have vector A like this and vector B like this. Okay, let me show you some examples. This is vector A, this is vector B. Or let's say this is vector A and let's say this is vector B. Okay, like this. This is vector A, this is vector B. Or let's say this is vector A and this is vector B. Okay, so this is vector A and this is vector B. So in all the cases, I want to use triangle of vector addition and see how the resultant looks like. So start off by any vector. Let's say I start with vector A. Okay, tail to head, take B's tail, and then end it over here. That's it. So this is vector A, this is vector B. Now the missing side will be the resultant. You should just form a triangle. So two sides will be known. The third side, which will be unknown, you can find it by just joining them properly. So this is going to be my resultant. So A and B can be replaced by one single vector over here. Is that right? Okay. All right. Sir, how to notice this while solving the problems? Meaning, which method to use? All the methods are equivalent, okay, Rama. So sometimes you might use triangle, sometimes you might use parallelogram, which we'll talk about. Both are actually the same thing only, you will realize. When there is a geometrical problem, you will use triangle and parallelogram methods. But when it is a number-based question, usually you will go to the formula-based methods or the component-based methods. As we solve problems, you will get more and more idea. So that is the reason why I'm also doing these questions on figure-based questions, where these figures, we have to solve it. We cannot use any formula. We obviously have to use the triangle law. So I'll just rearrange these vectors to make sure that they look like the missing sides or two sides of a triangle, and then we'll find the missing side. So if you start with vector A, it will be like this. Vector B will be maybe like this. Okay, and the resultant over here, this one, this would be the resultant. Can you see that? This is going to be the resultant. Is that right, everyone? So this is the resultant. So this was your vector A and this was your vector B. Similarly, in this scenario, what do we do? See this. First of all, vector A was like this and vector B was exactly opposite to it like this. So I go like that and I come back over here. Guys, there is no missing side in this scenario. Look at it. A bar was upwards, B bar was downwards towards the left. So what is remaining is nothing. The missing side over here is 0. So the resultant in this scenario is a null vector. Is that right? So this is how you can use the triangle method. Absolutely clear, Rama and Abhijit and everyone. Yeah. A lot of questions, Abhijit. Average is around 50 to 100, but it can go up and down depending from problem to problem. Okay. Now, let me also talk about something like vector subtraction together with this only, because subtraction of vectors is no different from addition of vectors, and that is something which you need to understand as we do this together, because a lot of people think subtraction of vectors is a new thing. No. What is subtraction of vectors? See, subtraction of vectors is nothing but subtraction is nothing but addition with a negative quantity. Addition with a negative quantity. Meaning, say for example, I want to perform vector subtraction of A bar minus B bar. I want to subtract these two vectors, A vector with B vector. It is the same as saying I'm actually adding A vector to the negative vector of B, because you can see this minus and plus will anyways become minus. It's like saying, guys, like this. What is 7 minus 2? It is like saying it is 7 plus negative 2, isn't it? So 7 units right side, negative 2 units left side, together will give me 5 units. So 7 minus 2 is same as adding negative 2 to 7, which will anyways give me the same answer. So this is basically your vector subtraction, and this will be your resultant vector. This will be your resultant vector. So say for example, let me give you, I have a vector A over here and I have some vector B over here. Okay, Chumma, I have taken some random vectors. Let's say this is vector A and let's say this is vector B. I want to subtract vector A and B. What do I do? As I can see, subtraction means addition but of a negative vector. Will I take negative of A or negative of B? As you can see, A minus B means I have to take negative vector of B. So B is like this, negative vector of B will be obviously like that, exactly the same value but in the opposite direction. Now forget this, okay, forget this, just look at this and this. Okay, so this is our vector A, maybe it is like this, and this is our negative vector B. So negative vector B is probably somewhat like this. So this is vector A, this is negative vector B. I have used triangle law. A vector and this negative vector, tail head. So as you can see, there are two sides of a triangle. There is obviously a missing side. The missing side of the triangle will be the resultant taken in the same order. So this is our net vector, which is the resultant of these two, which is actually the vector subtraction. So actually speaking, vector subtraction is vector addition. How many of you got this? Yeah, smash that like button right away right now and put a thumbs up out here. Yes, Gautam, that's absolutely correct. Uh, Definitely. Okay, Rajesh, I will definitely do that. Abhijit understood. Perfect, Rama. Yes. So sometimes visualization much tougher than what I do for physics. Yes, Rama. Visualization needs to improve over a long period of time. It can't happen in one class or one lecture. So usually I recommend my friends and my students, guys, to solve a lot of puzzles, to draw things which needs visualization, and whenever there is a physics question, always start with a drawing of those words or those statements. It's a statement based question. Draw by yourself, what do you think, and always visualize. Maybe there is a diagram or some question on pulley blocks, whatever. Try to think, how will it look from the top, how will it look from the side, how will it look from the front. This improves your understanding of concepts visualization wise. So this is one of the common tricks which I used on my 9th and 10th standard students who later on went on to become all India rank 10, 15, 2 and all of that. Where I used to give them some 3D objects, and I used to ask them, how will it look when you see it from the top? How will it look when you see it from bottom or left or right? What happens if I remove this part? And then puzzles on squares, cubes, cuboids, circles, spheres, cones, etc. All these puzzles, riddles, and always ask them to draw the situations, visualize it by drawing, not in your head, by drawing. Okay, so this will definitely help you. It takes a couple of months to improve it, but definitely you will get there. Okay, sir. So vector subtraction is technically vector addition. That's what we got to know. You have two vectors, you want to subtract them. You take the vector which has to be subtracted, negate it. So v vector over here has been negated. So this vector and this vector will give me the resultant vector subtraction. Okay, sir, got it. Sir, I have another doubt over here. Okay, this is also done. Okay, this is also done. Both addition and subtraction can be shown. Sir, can the addition of two vectors be interchanged in order? Meaning, instead of a plus b, can I write b plus a? Will I still get the same answer? The answer is yes. It is called as commutativeness. Like, for example, your mom asks you, hey, get 2 kgs of tomatoes and 3 kgs of potatoes. 2 kgs tomatoes and 3 kgs potatoes. Finally, when you come back home, what will she check? Have you bought 2 kilo tomatoes? 2 kg potatoes and whatever, tomatoes of 3 kilos. She will not be worried whether you went to the potato shop first or tomato shop first. Whether you buy potatoes first and then tomatoes, or tomatoes first and then potatoes. Finally, you will have potatoes and tomatoes. That is what matters. Same thing with vector addition. It is commutative. That means the order of performing the individual events does not matter in the final answer or in the final effect, right? But in our life, things are not commutative. I can't do 10th standard first and then 9th standard, or I can't do 12th and then 10th. No, it has to go in a specific order. That is the rule of life. So when the order of events does not matter in the final outcome, then it is said to be commutative. So commutative property means the order of events, or basically the order of operations doesn't affect the final outcome. Such a property is said to be uh, commutative property. So I take vector A and then vector B. The resultant is the vectors R, or whatever you want to call it over here. But let's say I take vector B first, which is exactly this one, the same vector B, and then I add vector A to it, and then I add vector A to it. So B vector and A vector again will give me the same resultant. In fact, it becomes like a parallelogram. Are you able to see that? Yeah, this is a parallelogram. I take this same vector A, as you can see over here, and I place it over here. And if you want, I'll show you vector B. That same vector B, I can also place it over here. Irrespective of how I add them, yellow plus orange or orange plus yellow, A plus B or B plus A, the resultant will be the same. So you can see one triangle here and another triangle here. Both are congruent to each other because the diagonal of a parallelogram creates two congruent triangles. So it is a parallelogram, and obviously the resultant is still the same. Yes, everyone with me? Good evening, Vasuki. Yep, always little late, but always there. I'm very happy that you're always there. Yeah, this is a parallelogram. In fact, I hate to break it, that this is actually the parallelogram law. And I was just talking about it. It doesn't really matter which law you use for vector addition. At the end of the day, they are all the same. This is exactly the parallelogram law. And let me just show it to you. By the way, I hope you understood A plus B and B plus A, they are the same. The order of the events does not matter for the final outcome. So if I show you the parallelogram law of vector addition, it is exactly this. You take the two vectors, the diagonal of that parallelogram becomes the resultant. But how do you perform parallelogram law vector addition? This is how you do it. Say for example, I have a vector A and I have a vector B like this. This I call it vector A and this I call it vector B. If I want to use the parallelogram law of addition, now do not put, say this is vector A over here, do not put vector B on the head of it, on the head of vector A. No, no, no. Now you put both their tails together. Yes, both the tails of those vectors should be together. The tails should be together. The tails should be together for parallelogram law. Remember, for triangle law, it was slightly different. If you go back, you will see tail, head. The next vector's tail is on the first vector's head. That was the rule for triangle to be formed. But for parallelogram, that is not the scenario, my dear warriors. It is the tails which are together. This is the first step. The next step is basically you complete an imaginary parallelogram. Just imagine a parallelogram like this line and this line parallel, this line and this line parallel, something like that. Now, once you draw these parallel lines, you will be able to draw a diagonal, not this one, from the common tail. You will be able to draw a diagonal from the common tail like this. That becomes your resultant. That becomes your resultant. So that resultant is nothing but the vector of A and the vector of B. This is how you add using the parallelogram law. So as you can see, if I shift vector B here, it becomes a triangle law. If I shift vector B back here, it becomes parallelogram law. So it's actually one and the same thing. It's just different perspectives of looking at the same thing. For parallelogram law, the tails are together, but for triangle law, you have to go with head, tail kind of an arrangement. Okay? Anything else will be incorrect. Is this absolutely clear, my dear warriors? Everyone? Yeah, definitely. Okay, great. Awesome, awesome, awesome. So, just to give you some more examples of parallelogram law of vector addition, let me come to it. Say, I give you one vector like this and another vector like this, maybe. Then one vector like this and another vector like this. Okay. I want to add these vectors using parallelogram law, A vector and B vector. So let's see how do we do it. Okay. Let's see how do we exactly do it. First of all, okay, I have A and B. Make sure that their tails are together. Make sure that their tails are together. This is one vector and this is the another vector. Okay, their tails are together. Same thing over here. Make sure that their tails are together. Okay, this is vector A and vector B is somewhat like this. Okay, fair enough. Now, next thing, draw a parallelogram. So this is a line parallel to this line. Another line parallel to this will be somewhat like this, maybe. Okay. Same thing here. Complete the parallelogram. Complete the parallelogram. Okay. Something like this. Okay. Parallelogram done. Once the parallelogram is done, now from the common tail, draw the diagonal. From the common tail, draw the diagonal. That's it. That is your resultant. So this is your resultant vector. This is also your resultant vector. Understood how to do it using parallelogram law? So both of these scenarios, I have just used nothing but the parallelogram law. parallelogram law of vector addition. If the same thing I had to do using triangle law, it would be giving me the same answer. It's just that it will look different. So using triangle law, it would probably look something like this. Maybe this is vector A, vector B will be somewhere like this, maybe. Vector B will be something like this. Still, I will get the same resultant. See, this resultant and this resultant is the same. It won't be different. Same thing over here also. If I do it using triangle law, this is, let's say, vector A, vector B, I should put it on this guy's tail like that. And that's it. This is the resultant. This is the resultant. You can see it's the same thing that you are getting, whether it is parallelogram law or whether it is triangle law. So I can just block this as the triangle law of vector addition. Same answer. So both of them are exactly the same. How many of you got it? Yeah. Another live is running. Where is it running, man? Which live is running? No live is running. Only one live is there. Oh, that is basically for your Sigma batch entry point. That is, yeah, that is for your entry point for all the students who missed yesterday's announcement, only for them. Okay. Yeah. Cool. So now that we have understood these concepts of parallelogram law of vector addition and all of that, so it's time that we solve some questions based on this. Okay, come, let's solve. Here is the question on your screen. A blind person, after walking 10 steps in one direction of each of length 80 centimeters, turns randomly to the left or right by 90 degrees. After walking a total of 40 steps, the maximum displacement of the person from the starting point can be. This is a very tricky question. Even if you don't know vectors, still you can do it. What's the maximum possibility that he can be far away from the original point? Maximum displacement that the person can have. Okay, so imagine the person is walking 10 steps in one direction. Maybe he's walking 10 steps like this. Randomly, he can turn towards the left or the right. Let's say he turns towards the left by 90 degrees after 10 steps. So each one of them is 10 units. This is also 10 units. Now let's say he again turns towards the left by 10 units, again turns randomly towards the left. Well, he will be back to his original position, and then the resultant will be 0, right? So every time if he turns left, then he'll be back to the same place. No, that is not maximum. I want the maximum possible displacement. Okay, let's say this person goes here, and let's say this person goes left, and maybe this person goes right, and again he goes to the right. Okay, so this is 10 units, this is 10 units, this is 10 units, this is 10 units. So if you see, from the starting place, he has reached over here. He has reached over here. How much will this resultant be? I think this is 10 units. This is also exactly 10 units. So 10 plus 10, which is basically 20 units from the starting place to the final location. Is that right, everyone? As you can see? Okay. Okay, great. Now imagine if I choose one more possibility. Let's say you go one place, you turn left, maybe again turning left is meaningless. Let's say you go away from as much as possible, and then again turn towards the left. Oh, now what will happen? Let's see. This is 10 units, this is 10 units, this is 10 units, this is also 10 units. So what is the resultant going to look like? The resultant will be like this, guys. The resultant will be like this. How much will it be? I think we can use Pythagoras theorem over here. Pythagoras theorem, how? This is base. This is basically the height. How much will the base be? This particular base be 10 units plus this 10 units, which is 20 units. And the height will be 10 and 10. So this will be also 20 units. So using Pythagoras theorem, how much will this resultant be? It will be root of 20 square plus 20 square, base square plus height square. So it is basically 20 root 2 units. So out of the three, which one is the maximum? Farthest displacement. This is 0, this is okay. This is 20 root 2, which is definitely the maximum. This is definitely the maximum possible displacement. So hence the answer will be, 20 root 2. But oh, wait a minute, that is as per the steps, but 10 steps is 80 centimeter. 10 steps is 80 centimeter. So if 10 steps is 80 centimeter, so 80 centimeter plus 80 centimeter will make it 160 centimeter. 80 plus 80 will again make it 160 centimeters. So centimeters wise, this was steps wise, 20 root 2 steps. This will be 160 root 2 centimeter, which is the same as saying 16 root 2 meter, because 100 centimeter is a meter. So it is basically 16 root 2, over here. Is that absolutely clear, guys? Everyone? Yeah, it should be with a decimal place. It should be with a decimal place, 1 point, yeah, 1 point something. Working, each of length is 80 centimeter. Oh, sorry guys. Each step is of 80 centimeters. That means if you basically, sorry, my bad. I thought total 10 steps in one direction. Each step is of 80 centimeters. My bad. Each step is of 80 centimeters. The total length will be 800 centimeters plus 800 centimeters over here, and same thing over here also, which will make it 1600 centimeters, which will make it nothing but 1600 root 2 centimeters, which after division by 100 will give me 16 root 2 meters. Yeah, this is perfect. So that is the answer. Okay, so this was as per the steps, but if you take in centimeters, you will get the answer as 16 root 2 centimeters. Is that right? Yeah. Okay, great. Let's move to another question coming up on your screen. Let's see whether you can do this. Two forces. Where is it? Two forces, each of value f act as shown in the figure. What do you think is the resultant going to be? Very straightforward. You can use triangle law, parallelogram law, completely up to you. So what do you think, guys? What is the correct answer for this? We can use triangle law. This is tail, head arrangement. It's already forming two sides of a triangle. There is a missing side over here. So if I draw the missing side of the triangle from the tail over here to the head. So now we have essentially used the triangle law of vector addition. Perfect. So 100%, this is the resultant vector. Now, as you can see, this is 60 degrees, this is F, this is F. So now it becomes an equilateral triangle. Equilateral triangle if it becomes, because included angle is 60 and both the sides are congruent. Therefore, the resultant must also be of magnitude F only. So it should be also magnitude F only, which is option D. Yes, perfectly correct, guys. Awesome, awesome. Great. Now that you understood triangle law and parallelogram law over here. So now let me show you the another important thing, which is basically the analytical method, meaning the formula method. Okay, formula method of adding two vectors. This is very useful because sometimes you might not be getting good angles, not good values. So in that cases, when magnitudes, angles are given, geometrically you are not able to solve it, you will use the formula method or the analytical method. So what is this analytical method? It's straightforward, guys. See, you have a vector A, you have a vector A, and you have another vector B like this, and using triangle law or parallelogram law, whatever you want to use. Sorry guys, once again, this is your vector A, and then you show this vector B. Okay, both these vectors are shown over here. This is vector A and this is vector B. By triangle law or parallelogram law, it doesn't really matter. You get resultant vector out here. This is vector A bar plus B bar, which is also our resultant vector. Resultant vector, which is A vector plus B vector. Okay. I want to find out what is the magnitude of the resultant. I also want to find out what is the angle which the resultant makes with any of these vectors. Okay. So our aim is, target is to find the green vector and in what direction is it. Okay. That's the whole idea. Now tell me, if I ask you what is the angle between A and B, a lot of students might immediately jump and tell, sir, angle between A and B vector is this. But do you remember, in the previous lecture, I have told you how do you exactly find the angle between two vectors. If you remember it, you will not make that mistake. In this particular lecture, I have given you how do you exactly find the angle between the two vectors. Yes, you have to make sure that both the vectors are, yeah, see over here only we have done this particular question on angle between the vectors and all of that. Yeah, both the vectors are placed tail to tail. This is how I have explained it. Yeah, always tail to tail or head to head. Only then we can measure the correct angle between the two vectors. Is this absolutely clear, everyone? So having said that, as you can see, the head of a vector is with the tail of this vector. So this is not the right angle. The correct angle will be the other angle, or shift this vector B over here. If you shift this particular vector B onto here, then you will see that the correct angle between A and B is this one. This is the correct angle, which is theta. Is this absolutely clear, everyone? Yeah? Okay. So theta is the angle between vector A and vector B, and then the we have to find the resultant's magnitude and the angle made with, let's say, vector A, that is basically angle alpha. This is your angle alpha. How do we exactly do this? It's nothing but Pythagoras theorem that has to be used. So they have labeled some points, like you can see over here, A point, point B, this is, let's say, point D, let's say this is point C. You do a geometrical construction like this so that this becomes 90-degree. And if this angle is theta, obviously even this particular angle is theta. Okay, so now what you do is focus your attention on this triangle over here, and also on this triangle over here, one small triangle and one big triangle. So if you look at that big triangle out there, which is triangle, okay, I've already put what we want to do in the previous slide. So if you look at triangle ADE, AD is the hypotenuse. So AD square will be AE square plus ED square. AD square will be AE square, which is the base, plus ED square. Now, what is AE? AE is nothing but AB length plus B length will give me AE length. So therefore, AD square will be AB plus BE. AB plus BE. So I just split A into AB plus B square plus ED square. Okay. Now expand this. So AD square will be, you will have AB square over here plus BE square over here plus 2 times of AB into BE plus ED square over here. So now I will do one thing. I have B square, okay. I also have ED square, which are the two sides of the smaller triangle. So I will group them together. So AD square will be AB square as it is plus 2 times, we'll put that later on, we'll put BE square plus B square plus ED square together, and lastly 2 times AB into B. Notice these two things, B square plus ED square. What is it? Using Pythagoras theorem again, it will be BD square. This will be nothing but just simply BD square, again using Pythagoras theorem. So AB square is as it is, AD square is as it is, and lastly we have 2 times AB times of BE. Okay, perfecto, sir. But what now, sir? I think I know what AD, AB, BD, AB and BE is. How, sir? How do you know that? Observe carefully now over here. What is AB? Technically, A bar's magnitude, which can be also called as A, is nothing but the length AB. This length is also the magnitude of vector A. Vector B's magnitude, I can just call it as B, which is also BD. So this is nothing but BD. Similarly, what is B and what is ED and what is this AD? This AD is nothing but a resultant vector's magnitude, which I can just call it as R. So that is nothing but A to D. A to D is the resultant vector's magnitude. Okay. And for that small triangle, as you can see, cos theta will be adjacent by hypotenuse. That means BE by BD, B by BD, which is the same as saying BE is, okay, BE only. B to D is B. So it will be B by BD. That is basically your cos theta. So therefore, I can write instead of B, I can write it as B also. So BE, which is nothing but B, is nothing but BD cos theta. Oops, sorry guys, I think I made a mistake over here. So sorry. BD was B, not B. So my bad. This BE by BD, B to D is nothing but B. Therefore, BE is nothing but B on the top, B multiplied by cos theta. Same thing over here. Sin theta is opposite side, which is D to E, upon hypotenuse, which is BD. But wait a minute, B to D is nothing but vector B. B to D is vector B's magnitude. Therefore, D to E is nothing but B times of sine theta. Is nothing but B times of sine theta. All the values I have got, just have to substitute it over here. So what is AD square? AD square, as you can see, A to D is nothing but R. So therefore, AD square will be nothing but R square is equal to, what is AB square? AB square is nothing but A square. So I'll just put A square over here, plus what is BD square? BD square is B square. So BD square will be B square plus 2 times of, what is A to B? A to B is nothing but A. A to B is nothing but A. What is B to E? What is B to E? B to E is nothing but B cos theta. So I'll just put B cos theta over here. So therefore, if I put R under the root, so it will be A square plus B square plus 2AB cos theta. This whole thing under the root will be the resultant. This whole thing under the root will be the resultant, guys. Yeah. So this is something which I need to block. So keep this formula in mind. Okay. So the resultant will be A square plus B square plus 2AB cos theta, whole thing under the root. So I have found out the resultant. But that was not the only question. We have to also find the angle alpha. So we can find that angle alpha like this. How? Observe carefully. Let me get rid of all these things. How do I find that angle alpha? I want to find out that angle alpha. So for that, okay, to find out angle alpha, look at that big triangle. Look at that big triangle again, ADE. In that, if you find tan of alpha, which is opposite side, which is DE, by adjacent side, which is nothing but A to E, I can write A to E as AB plus BE. It is nothing but AB plus BE. Okay. Why did I do it? Observe. What is DE? DE, I think I found it out over here. DE is nothing but B sine theta. So I can just put over there. as b sine theta, which I have already found. What is AB? AB also I found it out over here. It is magnitude of the vector A. So I can just put A over here. What is BE? BE is nothing but B cos theta. BE is nothing but B cos theta. So just put B cos theta over here, and I have found out what is tan of alpha. So alpha I can find it from here. So this is the angle made by the resultant vector. So this is the angle made by the resultant vector. As simple as that. Is that right? Okay, perfecto. Awesome, awesome, awesome. Now that you have understood it till here, sir, can you show me an example on this? Why not? Say for example, I tell you, for example, imagine vector A's magnitude is given as 4 units, vector B's magnitude is given as 2 units, and the angle between them is given as 60 degree. Find the resultant, and the angle made with the vector A. Okay, so how do we solve this? Just use the formula, nothing else. So resultant is root of A square plus B square plus 2AB cos theta. So A is 4, B is 2. Again, A is 4, B is 2. It will be theta being 60 degrees. Cos 60 is nothing but half. Cos 60 is nothing but half. Okay. Okay. 4 square is 16. 2 square is 4. 2 and 2 cancels. 2 4s are 8. 16 plus 4, 20. So it will be root of 28, which is nothing but 4 multiplied by 7. Root 4 is 2. So I will get 2 root 7 units. That is the resultant's magnitude. 2 root of 7. Similarly, we can also find tan of alpha. So tan of alpha being b sine theta upon a plus b cos theta. Theta is 60 degrees. Do not forget that as given. So what is b? B is nothing but 2. Sine 60 is root 3 by 2. Next thing, A is nothing but 4. B is nothing but 2. And cos 60 is nothing but half. Okay, perfect. 2 and 2 cancels. In the numerator, I have root 3. 2 and 2 cancels. It is 1. 1 plus 4 is nothing but 5. Okay, but do I leave the answer like this? Not necessarily. You can write alpha is nothing but tan inverse of root 3 by 5. So the options will also be in tan inverse. You are not required to remember or find out this particular angle. Just leave it as tan inverse. So when it is tan inverse, sine inverse, it means whose tan is root 3 by 5, or whose sine is this much, or whose cos is this much. That is the meaning of this inverse function. Like for example, if I ask you what is cos inverse 0, that means whose cos is 0. Oh, I know it is 90 degrees or pi by 2. Or if I say tan inverse of just root 3, whose tan is root 3? Well, we know it is 60 degrees or pi by 3 radian. So that is how that meaning is, okay, of inverse function of tan, cos, sine, etc. Is this absolutely clear, everyone? Absolutely. Shall we go ahead now to some more questions? Shall we go ahead to some more questions? Okay. So let's solve some questions. Okay. This was done. Let's see whether you can solve this beautiful question on your screen. Two forces of magnitude 2F and 3F are at an angle theta with each other. If the force is doubled, then the resultant also gets doubled. Then the angle is how much? The magnitudes are 2F and 3F, angle theta. If the force Q only is doubled, then the resultant also gets doubled. Okay. So in the first scenario, if you notice, in the first scenario, let's say the resultant is R. It will be nothing but P square plus Q square plus 2PQ cos theta. Okay, angle is not given, but P and Q's magnitudes are given, 2F and 3F. So this will be nothing but 2F whole square plus 3F whole square plus 2 multiplied by 2F multiplied by 3F multiplied by cos of theta. Okay, f is there common everywhere. So when you take it outside the root, it will just become f. Okay, 2 square is 4, 3 square is 9, 2 2s are 4, 4 3s are 12. So 12 cos theta, that is the resultant in the first case. Now let's talk about the second scenario. When the force Q is doubled, that means instead of 3F, it will become 6F. That's it. Other forces as it is. So the resultant also gets doubled. That means instead of R, I am getting 2 times of R. That will be nothing but root of, first magnitude is still going to be 2F, but the other magnitude is going to be 6F of the other vector, plus 2 multiplied by 2F multiplied by 6F times of cos theta. Okay, now they ask the angle. But wait a minute, I already know the value of R, so maybe I'll just put it over here, which is nothing but, 4 plus 9, I just didn't do it. Sorry guys, 4 plus 9, 13, 13 plus 12 cos theta. Okay, so instead of R, I can just put it as root of 13 plus 12 cos theta as it is. This number 2 will be as it is equal to, everywhere f square is there, but it is inside the root. So when I bring it outside, square root of f square will become f, and I will have root of 2 square is 4, 6 square is 36, plus 2 2s are 4, 4 6 are 24. So 24 cos theta over here. Okay. Now I think one f was missing. Sorry guys, this f was missing. Yep. Now as you can see over here, this f from here and this f from here will cancel out. Okay, perfect. So what do I have over here? We have that number 2 as it is, and equal to 4 plus 36 is nothing but 40 plus 24 cos theta, and here we have nothing but 13 plus 12 cos theta under the root. Obviously, we have to square both sides. The moment you square both sides, what will happen? 2 square will become 4, and multiplied by 13 plus 12 cos theta is equal to, here you will have 40 plus 24 cos theta. 40 plus 24 cos theta. Yes. Yes, I added Rama, F. Will you take multiplication and division? Not tomorrow, next class. I think it will come next week. Every day, every week we are having 2 classes of 11th, 2 classes of 12th per subject. So imagine 3 subjects every day, right? Yeah, every day you are having a class, right? And for 11th and 12th, right? Okay. So solve this, guys, and tell me what is the answer that you are getting. Solve this and tell me what is the answer that you are getting, my dear students. Yeah. Here you will get 52 plus 48 cos theta is equal to 40 plus 24 cos theta. Okay, I can take 40 over here, so I'll have 52 minus 40, and over here I can take 24 cos theta minus 48 cos theta. This will be minus 24 cos theta, and 52 minus 40, that is basically 12. So therefore cos theta will be minus 12 by 24, which is minus 1 by 2. Now whose cos is minus 1 by 2? Obviously 120 degrees. So 120 degrees. So hence the answer will be 120 degrees. Is this absolutely clear? Yes, very good. Awesome, Hema. No, not 60. Be careful, me issue. Okay. Cos 120 is negative half. It's in the second quadrant. All silver teacups. Sign is positive in the second quadrant. Cos is going to be negative value. Okay. Great. All right. So Paul, every week our timetable is same. I don't know how many of you realize it. Monday I'm coming and Thursday I'm coming. I think for 11th standard. Okay. And then again, 12th standard also, I think I'm coming on, if I'm not wrong, Wednesday and Friday or something like that. So our schedule is fixed, but we just didn't want to make it very public. But so we have made it very clear that every day 6 o'clock you are having your 11th standard classes, every day 12th standard classes at 8 o'clock. So very simple. If you just blindly sit over here at 6 o'clock, you know that there is a class for 11th. If you know blindly sit at 8 o'clock, you know 12th standard syllabus is going to be covered, right? Okay. Vector subtraction also we can apply the formulas? Absolutely, guys. So imagine if I write vector A bar minus vector B bar, and I tell you the angle between A vector and B vector is basically theta, and this is the resultant, then the resultant has a magnitude of, keep this in mind, this is going to be a square plus b square minus, instead of plus it is minus 2ab cos theta. That's the only difference, that's it, which you should remember. Lot of times you might be asked questions on this. So for vector subtraction, okay, wherever you saw that plus, instead of that you have minus 2ab cos theta. Let me show you a beautiful example on that, which came in JEE. Okay, oops, sorry. First we'll come to, okay, we'll do one thing. We'll solve a question based on that. We'll solve a question based on that like this. And then we'll go to that question, because for that IJK, we need to see one more thing. Imagine I tell you, example, A vector plus B vector mod is A vector minus B vector mod. Question is find angle between A vector and B vector. That is the question. Okay. Find the angle between A vector and B vector. See, try to understand the question. This means A vector plus B vector mod means the resultant of their vector sum. The resultant, or the magnitude of the resultant, the magnitude of the vector sum, and this is the magnitude of the vector subtraction, they are basically the same. Then find the angle between them. Magnitude of vector sum, I already know there is a beautiful formula, a square plus b square plus 2ab cos theta is equal to magnitude of vector subtraction. The formula is a square b square minus 2ab cos theta. Okay, so this is a mathematical way of writing the same thing in different ways. Okay, so remove the square root from both the sides. Okay, remove that square root from both the sides. Okay, so what am I left with is nothing but a square plus b square plus 2ab cos theta is also a square plus b square minus 2ab cos theta. Oh my god. Guys, a square, b square got cancelled. So I am left with 2ab cos theta is equal to minus 2ab cos theta. Shift this guy over here. So it will be 4ab cos theta is nothing left on this side. A is not 0, B is not 0, 4 is not 0. So the only culprit is cos theta. So these are the probable suspects. Who is 0? Why is RHS 0? Because one of them is 0. 4 can't be 0, it's 4. A and B non-zero things. So cos has to be 0. So cos is 0. That means theta is 90 degrees. So that is the answer. Is this absolutely clear, everyone? Polygon law of vector addition, we'll come to that. And then we will go to the component method as well. Whenever you have more than two vectors to be added, then you use polygon law of vector addition, as simple as that. And what is this polygon method? Say you have vector A, vector B, vector C, vector D like this, and all these vectors need to be added. This is vector A, this is vector B, this is vector C, this is vector D. Then start with any of these vectors. Let's say you start with vector A, it was like this. Then let's say you go to vector B, which is, let's say, like this. Then you go to vector C, which is, let's say, like this. And then you go to vector number D, which is, let's say, like this. These are your vectors. Now you can see there is a missing side of a polygon. From here to here, you started from here, you ended here. Start drawing a ray from the tail to the head. Tail of the first, head of the last. That becomes your resultant vector. So this resultant vector is just the vector sum of A vector, B vector, C vector, and D vector. So always try to make a polygon. You will always see some kind of a polygon will be formed most of the times like this. Maybe this is vector 1, then vector 2, then vector 3, then vector 4, maybe then vector 5, then maybe vector 6. Okay, fair enough. So the resultant will be this much. So this is nothing but polygon method of vector addition. Sometimes it might happen that when you are adding in this process, okay, when you are adding in this particular process, the last vector coincides on the first vector's tail. So in that case, obviously, because you're coinciding, it is a complete polygon, the resultant will be a big fat 0. So this happens when all the vectors being added, all the vectors being added form a closed polygon. They begin to form a closed polygon. That is when this will happen. Is this absolutely clear? But if there is a missing side, then the resultant is not 0. So this is definitely having a resultant which is not 0 because it was an incomplete polygon. For an incomplete polygon. Incomplete polygon. For a complete polygon, the resultant will be 0. Clear, guys? Okay. Now, the last property over here is associative property, meaning whether you add A and B first and then add it to C, or you add B and C first and then add it to A, doesn't matter. The result will be the same. It's like an extension of, you can say, commutative property and all of that. So, whether I take A and B first and then add it to C, or B and C first and then add it to A, or B and D and C first and then add it to A, doesn't matter. You can take any first and then anything at the end. The result will be the same. That is, how do you associate? A and B are associated first, or B and C are associated first to then A. The result will be the same. That is called as the associative property of the vectors. Okay, fair enough. Now that you understand how this law of polygon works, let us also talk about, where did it go? Yeah, the maximum and minimum of the resultant. This is very, very crucial, guys. Observe carefully. If I want the resultant to be maximum, then the two individual vectors, if I have multiple options of the angle between them, I'll make sure that they are aligned in the same direction. Meaning like this. This is vector A and this is vector B, so that their resultant is as maximum as possible. This is vector A, this is vector B. This resultant is the maximum possible resultant. The angle between A and B is basically 0 degrees, or they are just parallel to each other. In such a scenario, the maximum value comes out to be just A plus B. Okay, just A plus B. Take the magnitude of A, take the magnitude of B, and just add them. That is the maximum possibility that you can ever get. Let's say you take one vector like this and another vector like this. That means exactly opposite of each other. This is vector A, this is vector B. The angle between them is 180 degrees, or I can say they are anti-parallel. Then the resultant which will be there, it will be very small. That's the least value because you're opposing. Most of it will be cancelled. This will be the minimum resultant possible, and this minimum resultant will be A minus B. A minus B, bigger vector minus smaller vector, but usually I don't know whether A is big or small. So to give that benefit of the doubt, we put a modulus. So modulus will take care of everything because magnitudes always have to be positive. So big vector minus small vector will be the remainder vector. That's the smallest that you can get. No matter what you do, whether A and B are like this or A and B are like this, the resultant that you get in all these cases will be lesser than this, but it will be more than this. So in general, the resultant will be lesser than, or rather it will be lesser than R max and it will be more than or equal to the minimum one. What is the maximum value? It is nothing but A plus B. What is the minimum value? It is A minus B mod. What is R technically speaking? R is the magnitude of the vector resultant. So it is A bar plus B bar modulus. That is more than equal to mod A minus B. You would have seen this in many places in the questions, or you will see it when you solve the questions. A plus B, which is pure addition, is the max value of the vector addition. A minus B, the mod, is the least value of the vector addition. Any time else, the values will be somewhere between them. It can't have more than this or less than this. Is this absolutely clear, my dear warriors? Yeah. Okay. So, just to summarize over here, when I have two vectors and I want to get maximum resultant, I will align them together. So I'll get maximum resultant. That means angle between A and B is 0, or they are parallel direction. So this length and this length will be the final vector's length, A plus B. When I want to get least output resultant, so one vector will be opposite to the other vector. So whatever is remaining will be the resultant. A plus B will be magnitude wise A minus B. So anytime else when the angle is acute or obtuse, you will see that the resultant will be lesser than the maximum value and it will be more than the least value. R max is A plus B, R minimum is A minus B. R is a resultant. Resultant means what? Resultant means what? Resultant means it is technically, it is A vector plus B vector. But just R means the magnitude of A vector and B vector. That's why I put that over here as the mod symbol. Is that absolutely clear? Yeah. Girish, we can do that, but that will increase the lecture time unnecessarily, and we already fall short on time most of the times. I usually extend my classes, but wherever possible, I'll definitely try to recap it. Okay, clear, done, dusted. Yes, perfect. All right. Let's see whether you can do this question. The resultant force of 5 Newton and 10 Newton cannot be. The resultant of 10 Newton and 5 Newton cannot be. Think about it. What can be the maximum value that is possible? You can have 5 and 10 together. 5 and 10 together. So it will be 15. What is the minimum value that you can have? 10 minus 5. Or if you want to say like this, do 5 minus 10 mod, which is anyways going to be 5. So your resultant can be somewhere between 15 and 5. Can be somewhere between 15 and 5. So 5 is possible, 8 is possible, 12 is possible, but as you can see, 4 is impossible. No matter how you do it, you can never ever get 4 because 4 is less than 5. Is this clear? Very good, Gautam. Awesome, Rama. Perfect. Let's do another question on this. The maximum and minimum values of the two vectors resultant is 17 and 7. If both of them are right angles, then what is the magnitude of the resultant? Very beautiful question. Let's see. The maximum value is 17 units, and we know maximum value is A plus B. Therefore, A plus B is 17. The minimum value is 7. We know the minimum value of the resultant is A minus B, A being bigger. Therefore, A minus B is 7. Okay. What do I do from this? Just add these equations. So if I add these two equations, I will have A plus B minus B will be 17 plus 7. 17 plus 7 is 24. BB went off. So I'll have 2A. Therefore, A is nothing but 12. If A is 12, how much is B? So use this equation. 12 plus B is 17. Therefore, B is 17 minus 12. Therefore, B is nothing but 5 units. But that's not the question. The question is if both of them are perpendicular to each other. If both of them are perpendicular to each other means A is having 12 units, B is having 5 units. and we have to find what their resultant will be. What their resultant will be. So obviously we can use Pythagoras theorem. It will be 12 square plus 5 square. So 12 square is 144, 5 square is 25, which will make it root 169, which is nothing but 13 units. So the resultant should be D option, which is 13 units. Is this absolutely clear, my dear warriors? Yes, perfecto. Amazing. Loved it, guys. The way you guys are answering. Keep it up. Kudos to all of you. Now, the last thing over here is vector addition by components or vector subtraction by components. This is the most difficult method. This is going to blow your mind. Okay. Say for example, I tell you vector A is 3i cap minus 2j cap plus 5k cap, and vector B is equal to 2i cap plus 7j cap minus k cap, and another time vector A is 5i cap plus 3j cap minus 2k cap, and vector B is I cap minus 2j cap plus 7k cap. Okay. In the first case, I want to add, and in the second case, I want to subtract. First case add, second case subtract. The most difficult thing to do in the world. The final answer of A vector plus B vector, what will you do? Just take the components individually and add them, nothing else. 3 plus 2 is 5, so 5i cap. Minus 2 plus 7 is going to be plus 5. And plus 5 minus 1 is going to be plus 4. So this is the answer of the resultant. So difficult to add. 3 plus 2, how to do, sir? Minus 2 plus 7, plus 5 minus 1. If I want to do subtraction, A bar minus B bar, do normal subtraction, but for each component separately. 5 minus 1 is 4. 3 minus minus will become plus, so it will become 5. And here, minus 2 minus 7 will become minus 9 k cap. That's it. That's how you do vector subtraction. So whenever you have to do vector subtraction or addition by components, just take care of the individual components like a normal addition and subtraction. That's it. Isn't it scary or crazy or simple or difficult or very easy? Yeah? Rama, you have completed all the PYQs, HC1 of electric field and chapters now. Start advanced PYQs or go to the next chapter. Start with the advanced PYQs. Okay. And if guys, you show even more support, if you get more students onto the channel, trust me, it is completely on you. It is not on me. A lot of you think that it is on me. No, it is on you. Then I will be starting problem solving for all of you. And for 10th standard also, if you guys want a foundation for J and 9th standard also, then we can start with that. It's completely on you. So it's all up to you whether you want the best teachers in the country for JEE and NEET preparation, whatever the foundation plus the problem solving for JEE Advanced and JEE Mains, whether you want it or not, completely up to you. Okay, and imagine all of this happening in English. Well, Hindi channels are there, but many students prefer to learn in English. Number one. Number two, we have the best team out here, right? We'll do it. It's very easy, no? Chumma guys, I was being sarcastic. Some people are thinking, sir, I'm not finding it difficult. Why is it easy? But you are saying difficult. Am I missing something? Guys, I was being sarcastic. My God. Okay. Please don't get scared. All right. So let's do a question on this maybe. The magnitude of x and y components of A are 7 and 6. Also, the magnitude of x and y components of A plus B are 11 and 9. Calculate the magnitude of vector B. Oh my God. Vector A, vector B, vector A plus B. Okay, fair enough. And here we'll put x component, here we'll put y component. So think about it, what is given over here. A has the component 7 and 6. So this is 7 I cap plus 6 j cap. A bar plus B bar is 11 I cap plus 9 j cap. Question is, what is B? Come on, use your head and quickly think and give me the answer. Which number plus 7 will give me 11? Isn't it obvious? It will be the number 3. Which number plus 6 will give me the number 9? It will be 3 again. Is that right? So 6 will add up to 3 to give you 9. 7, oh sorry, why did I put 3 over here? My bad. So sorry guys. 4 number. Number 4 plus 7 will give me 11. The question is, what is the magnitude of vector B? Okay, so magnitude of vector B will be root of 4 square plus 3 square, which is 25's root, which is 5 units. 5 units is option B. Perfectly correct, guys. Done, dusted. Yes, option B. Awesome, isn't it? That's how you need to do these questions. So sorry, guys. So sorry. I think my voice was not audible. Yeah, thank you so much for pointing it out. I was saying, so that was the last question which we did, and I hope you guys enjoyed the vector addition and subtraction part, and we have completed the theory for that. Next lecture we'll be doing cross product and dot product, the vector multiplication, the final chapter or the final topic. After that, we'll go to motion in 1D and 2D. Okay, so if you are looking for a personalized way of coaching, you want the complete mentorship, the coaching modules, live classes, you want a proper offline or online experience, we have both the options open for all of you. And my dear warriors, we have one of the best teachers in the country producing top ranks, like this year 99.99 percentile in physics. We also had J advanced rank 15, we have ISR rank 1 all India. So these kind of results have been produced by our online and offline batches out there. So please take that help when needed. Just don't depend on YouTube. Obviously YouTube is always there to help you, guide you, but if you want that hand holding, you want that doubt support, you want the modules, you want the test series, you want every single thing, then you should be a part of the batch. There is no doubt about it. Either online, you can check out by booking this demo out, okay, or if you want to explore our offline centers, please do explore our offline centers. They are located in multiple cities across the country. Okay, so the notes will be available in the description box after some time. Okay, have a great time and all the best. Please like the video and subscribe to the channel. Bye bye, take care.